Let's review today's interview question, which is if we can write an efficient function that checks whether any permutation of an input string is a palindrome. So given a string, we need to know whether any permutation of it is a palindrome. First, what is a palindrome? This string is not palindrome because if we write it from both sides, from these sides, from the right side to the left side and from the left side to the right side, then we get two different strings. From the right side to the left side we just wrote, and from the left side to the right side we have C, B, A, and these strings are not equal. So this string is not a palindrome. Now let's get to a string which is a palindrome. This string is, for example, a palindrome because you see, if we read it from the left side to the right side, we get this string, and if we read it from the right side to the left side, we get which is the same exact string. So this is a palindrome, a string which you can read, a string which is the same no matter from which side you read it. Now the question was not just if a string is a palindrome, but also if any permutation of it is a palindrome. So given any string, you need to check like all of its permutations and to see if it's a palindrome. So if we had ABC, then all of its permutations are first ABC, then CB, ACB, then BCA, then CAB, and CBA, and BAC. The formula for getting the number of permutations is simply it is n factorial. Why is it n factorial? Because when we had ABC and we want to get all permutations, then we need to fill in like 3 places. Okay, we have only 3 letters. So we first need to fill in the first one. We can choose any of the 3 letters. So we can choose like from 3 places. So we have 3 choosings. Let's say we have chosen one. Now we need to choose the second place. We can choose any of the subsequent 2 letters. So we have 2 choices left. And for each such 2 choices, we get left with only 1 letter, and we have to put it here. Okay, so for this one we had 3 choices, then we had 2 choices, then 1, which is n factorial. So now that we know how to find all permutations and how to find whether a permutation is a palindrome, let's get back to the question. The question was simply that given a string, we need to tell whether this string is a palindrome, but not only whether this string is a palindrome, also if any permutation of it is a palindrome. If there is enough for one permutation to be a palindrome, then you return true. If no permutation is a palindrome, you return false. Okay? So the first way you could think about it, and this is the recommended way also in programming interviews, that your first way of checking this is by brute force. So how can you do this by brute force? You find all the permutations and then you scan each so the algorithm would be find all permutations, and 2 for each permutation, check if palindrome. Okay, if yes, return true, otherwise false. Otherwise, if all are not palindrome, false. So how much time this first section takes? Well, we know that finding all permutations is n factorial, and then you need for each permutation to check whether it is a palindrome or not. How much time would it take you to check if a permutation is a palindrome or not? You need to go through all characters, scan them from left to right, and see if the right to left is the same. But you can do it better. You can simply have 2 pointers. Okay, this will be 2n, and you can have also, but you can also have 2 pointers, and you check if the last letter is equal to the first letter. It's not, so you cannot read it the same way from end to beginning and from beginning to end. So you can do this with n with the 2 pointers where you move to each side, and this one is n. So the time complexity for this algorithm is n factorial multiplied by checking each permutation if it's palindrome, which is n. So it's n factorial times n. But this is the brute force solution. Let's think if we can have a better solution. A better solution would be to find some characteristic of palindromes and not. So let's draw one which is we already know which is not a palindrome. This is not a palindrome. Okay, how many A's do we have? 1. How many B's do we have? 1. How many C's? Let's find something which is a palindrome. Okay, so when we scanned it from left to right and from right to left with 2 pointers, note that every time we move the pointers to here and to the right, we need to make sure that the current pointer is pointing to the same character. So this one is the same character, also this one is the same character, and this is the only character, so it's good enough. So we have couples. So it's like you have to have couples of the letter whenever you move the pointer. So the characteristics that we are finding for a palindrome is that 1, each character appears evenly. If every character appears evenly, then you can reorganize them such that you take every pair from the even number. If it was 4, you take these 2 maybe and put them at the ends of the string. You take then these 2 and you put them at the ends, and then you move the 2 pointers and you get to a palindrome. So you need to have pairs of the chart. Now this is of course except for the middle character. If you have 5 characters, then this one is a pair, this one is a pair, and this one not. Okay, so if you have any even number of characters, pair, and not even one even. So it looks like there should be only one character which is not paired with another. So we can improve the algorithm to actually find this only character which is not paired with another character. So how can we do that? Well, in many programming interviews, the first thing which would come up to mind is a hash map or a hash set if you need. So what you can do is have a hash set for each character. Let's say we scan the ABC. So we get to first A, so we put it in. We get to a B, we put it in. It's a set, okay? We get to C and we put it in, okay? And then we ask ourselves, do we have more than character here? Yes. Let's take an example of a palindrome. We get to A, we put it in. We get another time to A, we remove it. We have a pair. Okay, we are here now. We get to B, we put it in. We get to A, we put it in. We get another time to A, so we remove it. And at the end, we are resulted with the only character which is not paired. And in this way, we know that this is a palindrome because it has only one character in the set, only one. Okay, if you had two, then you had two that you could not pair, and you could not have two pointers with the same character, because only the middle one is allowed in the palindrome to be such a character. Now let's move on to see how to code this. So the way we write that code is that we first convert, whenever you have a string in a programming interview, it's best to convert it to a char array. So we are going to have a set, we are going to have first the char array, so it's char our string, let's say it was s, to char array. Okay, now that we have the char array, let's traverse it and fill in our set, but let's first define our set of pairs. So it's set of character of non-pairs. Alright, of non-pairs, which is new hash set. Okay, now that we have it, we scan each character. So for char C chars, and for each such char, we check if it's already contained in the set, and if not, we put it. So let's check if it's already contained. If non-chars contains the character, if it doesn't contain, we need to put it. So we just if it contains it, we remove it. Okay, so it contained it. So if you remember, when it contained it something and we saw it, we removed. So we see it again, it contained, so we remove it. So let's remove it from it. The removal would be non-chars dot remove. See, and if it's not there we simply add it. Okay, and then the result should say if this char array, if this chars was a palindrome or not. Well, it's simple. It's simply if the size of the non-paired chars, which if you remember was a set, a hash set, if its size is less or equal to 1. Okay, if it's only 1 or 0, then we have a palindrome of a permutation of these characters. So I hope you enjoyed this episode. Thank you for listening, and I will see you next time.